Hello, class. How are y'all doing? I hope everyone's doing fine. Um, I'm doing good. You know, trying to get through all this. I just want to let y'all know that if you didn't pass the fifth 6 weeks, you can go back and do that. You can do those assignments. They start on March 23rd, and then move yourself up. Everything's in Google Classroom. Um, let's see what else. Um, I don't. So it just came out today that y'all won't have final exams, which is a good thing. That's good for you and me. Um, Glad that's happening, but that doesn't mean that the semester is over. So we are done at the end of on June 4th. I think is the last day. So y'all need to keep working on what I'm sending out, and let's see, finish strong. Okay, that's the best way to do this. All right, so let's get after this. Okay, so now we are into gases. We're in the unit of the gas laws. So first gas law is going to be Boyle's law. All right, so you should have already seen an introduction to this. I should have put it out um, about a day ago. So um, what's happening here is that you need to understand that we have variables in these gas laws, and these gas laws, and some of these variables are going to be pressure, which you can see here. Okay, pressure, which is going to be denoted by uppercase P, uh, and it's going to be measured in kilopascals, which is going to be denoted by kPa, and also pressure would be denoted by atmospheres. That's going to be the unit, which is going to be an ATM. So whenever we're talking about pressure, we're talking about force. Okay, the force of the particles hitting inside a canister. All right, and we'll be doing a lab here pretty soon, and I'll walk you through that, and you'll see how the particles hit the inside of the canister and also each other. So if we get so pressure is going to be uh, the force over the surface area, okay, of whatever canister it is. So that brings us to volume. Volume is going to be denoted by uppercase V. We measure that in liters. So whenever, like it says here, whenever we inflate a balloon, we are adding gas molecules to the balloon. All right. So you're adding carbon dioxide molecules into the balloon. All right. So when you blow into a balloon, you're actually giving that balloon more volume. Okay. So the balloon is elastic, which means that it's able to expand. And so when you blow the air into it, you are giving it more. You're giving it more volume. Now you can exceed that volume of the balloon, and then obviously that it ends up popping because you've exceeded its elasticity. All right, so um, the degree of gas temperature. Okay, we're going to use temperature in Kelvin. Okay, so temperature is going to be denoted by T, and we'll be using temperature in Kelvin. It's not going to be Celsius. It's not going to be Fahrenheit. It's going to be um, a unit known as Kelvin. All right. Also, another variable is going to be the amount of moles that are inside the canister. Okay. So the amount of gas and volume uh, and temperature are factors that are going to affect the gas. And so whenever we go through the lab, you'll see this. All right, let's go to the next slide here. So Boyle's law tells us about the relationship between volume and pressure at a constant temperature. So you're going to see that when we go through these laws, you're going to one of the variables is going to be something that is going to be constant. All right, so this word constant here, that means that one variable is not going to change. All right, so in this situation, Boyle's law, um, the temperature will not change. We'll keep it at, we'll say, I think during the lab it's 300 degrees Kelvin, or 300 Kelvin. All right, the only two things that are going to change are going to be the volume and the pressure. Okay, so the law states that pressure is inversely proportional to the volume. Okay, and so we have this down here this equation telling us of Boyle's law, which is P1 V1 equals P2 V2. Okay, and so that's actually P1 times V1 equals P2 times V2. All right. So inversely proportional means that, let's say if volume goes up, pressure is going to go down. So inversely means that it's going to have the opposite effect, and vice versa. If volume goes down, pressure is going to go up. And so through the lab that I'm going to give you in a bit, you will see that. Okay, you will see how this works. Okay, you'll get to understand it better. All right. So during Boyle's law, we are messing, the factors that we're messing with are volume and pressure. And then temperature is going to stay constant, which means it's going to stay the same. So volume and pressure will change, temperature will stay the same. All right. Let's see here. So here's a little deal here, a little just uh, a picture of how this works. Gas pressure is inversely proportional to the volume. Okay, so pressure and volume. All right, that's what we're messing with here. Temperature is held constant. All right, here's that equation. See, T equals constant, which means that it's not going to change. So you can see here, if you have volume, right? Okay. Um, this first canister, the one that has, that is not pushed down, okay, the one that's all the way up. So the pressure in there is not going to be very high, okay. But once you push down the pressure on this, okay, once you push down this plate and you cram all the molecules together, okay, that means that volume is going down, which means that the molecules can smash up against the walls and each other as much as it, what's the word, more frequently. Okay, so the molecules smash up against the walls and the other molecules more frequently, creating pressure. Okay, I think you all know. Okay, and that's going to be at 200 degrees temperature. I'm trying to think of an example. um I don't know if you ever messed with a baster before. Okay, one of those things that looks like a syringe, but you use it for food. Like you can inject like marinade into like briskets or something like that. Well, if you take the needle off and you pull the syringe all the way out, and you put you put you know the the opening at the end. Okay, you take the needle off, and then you put pressure on it, right? You put pressure on the on the syringe part, right? The part that you push. If you put it against your hand and you push it as much as you can, it starts building pressure inside of it. So then when you let go, it makes like this psh sound, right? So if you ever messed with one of those, you can understand what I'm saying. Um, I'm trying to think of another example. Um, Same thing with a balloon. If you try to push the balloon to the max, right? Um, the pressure inside is going to build, but once you let go of it, it it releases it. It releases the air coming out of the part that you're blowing the air into, and so the pressure is relaxed. Okay, so those are some examples, and with the lab, I'll show you how this works. Okay, let's see. Do we have anything else here? All right, so this is the end of this video here. So remember, the things that we're working with are Boyle's law. Okay, Boyle's law has to do with volume and pressure. Okay, and temperature is going to stay the same. Okay, those are going to be the variables. The variables are going to be volume, pressure, temperature. Okay, and so um, we're on to the lab.